Hey everyone! Today, we're diving into two of the most critical utility systems in any plant, but they're ones you almost never see: instrument air and nitrogen. They are the absolute lifelines for a safe and reliable operation. So let's pull back the curtain and see why the stuff you can't see matters the most.
So let me ask you a serious question. What's the one invisible force that can bring your entire operation to a screeching halt? Yeah, it's a utility you can't see, can't smell, can't taste, a loss of instrument air or nitrogen. That's not just a little problem. That can trigger a full-on plant shutdown, sometimes in a matter of minutes. The stakes are just incredibly high.
And that really gets to the heart of what we're talking about today. The things you can't see can have massive, very tangible, and often very expensive consequences. Understanding these systems isn't just a good idea, it's absolutely fundamental to your job as a professional operator.
So here's our game plan. We're going to start by framing this as the emergency it truly is. Then, we'll break down the specific jobs of air and nitrogen. We'll look at how things go wrong, map out exactly what you need to do, and then wrap up with a safety warning you just cannot afford to ignore.
Okay, first things first, we need to get our heads in the right space. A loss of instrument air or nitrogen supply, that's not just some abnormal condition on a screen. That is an emergency in progress. And how you react in those first few minutes can change everything. All right, let's kick things off with instrument air. I want you to think of it like the nervous system of your entire plant. Seriously, it's the force that powers all your control valves, sending the signals that open, close, and fine-tune, well, everything. And for a nervous system like this, quality is everything.
And you can't just use any old compressed air, right? Regular plant air is a control system's worst nightmare. It's chock full of oil, dirt, and water. Instrument air, on the other hand, is squeaky clean, and, this is the most important part, it's bone dry. Here's the key takeaway. When it comes to keeping your plants under control, the quality of the air is way more important than the pressure.
And that quality is protected by a whole chain of equipment. You've got the compressors making the air, the coolers, the dryers, and filters cleaning it up. Every single piece is a critical link in the chain. And if one link fails, the whole system, your whole plant's control, is in jeopardy.
Now, of all those links in the chain, you could make a strong case that the air dryers are the real MVPs. They have one single solitary job: to act as the ultimate guardian against moisture. They have to pull that water vapor out of the air before it has a chance to do any damage downstream.
So how do we actually measure how dry the air is?
We use a term called dew point. It sounds kind of technical, but the idea is really simple. It's just the exact temperature where all that invisible water vapor floating in the air will condense and turn back into liquid water, which is our enemy. All you need to remember is this: a low, steady dew point means your air is dry and safe. If you see that dew point starting to creep up, that is a major red flag.
Never, ever forget this. It's a simple truth, but it's a powerful one. As soon as liquid water gets into your instrument air lines, it starts causing corrosion, creating blockages, and making valves fail. It is public enemy number one for reliable plant control. Period. Okay, so we've talked about the plant's nervous system. Let's switch gears and talk about its bodyguard, nitrogen. If instrument air is what provides control, nitrogen is what provides protection. Think of it as a proactive safety system, designed to stop disasters before they even have a chance to get started. So how does it protect the plant? Well, it does it in three main ways. It does something called inerting, which just means it pushes all the oxygen out of a space to prevent fires or unwanted reactions. It purges lines and equipment to clean them out. And it provides a blanket over liquids in tanks to stop them from reacting with the air. It's a silent, invisible protector on the job 24/7. So now we know what these systems are supposed to do. Let's talk about what happens when they fail. And the crucial thing to understand here is that things can go from bad to worse incredibly fast. A small problem can cascade into a full-blown unit trip in just minutes.
These are your early warning signs: a low-pressure alarm, a dew point that's starting to trend up, a compressor trip. These aren't just minor annoyances. They are the first signals that your control and safety systems are under threat.
This is the domino effect in action. It all kicks off with one tiny failure. Let's say an air dryer malfunctions. Suddenly, moisture is just flowing right through the system. That wet air travels down the lines, cools off, and condenses into liquid water. That water then starts to rust and corrode the sensitive guts of your instruments. Next thing you know, critical valves are sticking open or slamming shut. At that point, you've lost control. the unit is unstable and a shutdown is coming. Guaranteed.
So how do you stop that chain reaction? You have to shift your mindset from being a passive monitor to being a proactive defender. This is your action plan.
Proactive defense starts with knowing what good looks like. You have to be a trend watcher. Is my system pressure stable? Is the dew point low and flat? Are the compressors just humming along like they should? Knowing your trends is so important because it lets you spot a problem long before the big red alarms start flashing.
But if the supply does start to fail, your actions have to be fast and deliberate. Your number one priority, always, is to protect the integrity of your control system. Keep those critical valves working. To do that, you've got to immediately reduce the severity of the process. Lower your rates, cut back your loads, make the unit as stable as possible. Then you communicate clearly to everyone what's going on, and you follow your plant's specific emergency procedures to the letter.
We've spent a lot of time talking about how nitrogen protects the plant, but now we need to talk about something just as important, how you protect yourself from nitrogen. And we have to treat this topic with the absolute gravity it deserves.
Here's the deal. The very thing that makes nitrogen so useful is also what makes it so incredibly dangerous. It displaces oxygen, and it gives you no warning at all. No color, no odor, no taste. You have no idea it's there. In any kind of enclosed area or confined space, a nitrogen leak can create a deadly, oxygen-deficient atmosphere in seconds. Let this sink in for a second. This is not an exaggeration, it's a fact. Underestimating the risk of nitrogen has led to fatalities all across our industry.
And why is it so dangerous? Because it only takes 1 or 2 breaths in an atmosphere that's mostly nitrogen to lose consciousness. That's it. There's no time to react. You don't feel like you're suffocating, you just pass out.
And that's the bottom line, really. Being a professional isn't just about running the plant well, it's about running it safely. And that means having a deep, unwavering respect for the hazards you simply cannot see. So, I'll leave you with this question to think about. Every alarm, every trend, every single pressure gauge, that's a signal from these invisible systems. They're trying to talk to you. As the first line of defense for your plant's safety and reliability, the only question is, are you listening?